Hello, thank you for watching section 12.5. Today we'll be solving multiplication equations. Looking at our multiplication equations, we have to keep in mind the same thing we kept in mind when we did addition and subtraction equations. Okay, whatever you do to one side of the operation, one side of the equal sign, you must do to the other to keep it equal, to keep that equality. So looking at the equation 2x equals 10 here, this is a multiplication equation because 2 is the coefficient. It's the number being multiplied by x. Okay, so this means 2 times x equals 10. We don't write multiplication. We've been talking about that in class. You don't write multiplication once you get into more algebra type lessons. They just assume you know that 2x means 2 times x. Okay, multiplication and division are inverse operations. So to solve a multiplication equation, you're going to use division. And we've talked about that before as well. The inverse operation of multiplication is division. So when we use division, remember you must do to one side as you do to the other. So we would be dividing both sides of the equation by the same number. Now the goal is always to get the variable, the x, by itself. So when I take 2 divided by 2, you get 1, not 0, because we know 0 times any number is 0. But you're going to get 1 because 2 divided by 2 is 1. 1 times x could just be written as x. Okay? Then I'm going to take 10 divided by 2, which is 5. And that is my solution. X equals 5. You can always plug it back in. 2 times 5 equals 10 to check your solution. Okay? So whatever you do to one side, you must do to the other. When we solved our proportions, remember we had this part of the problem at the end, and we divided both sides by 2 so we would get the x by itself. The reason we divide by 2 is to get x by itself. You do it to the other side to keep it equal. Okay, so 10 divided by 2 is 5. So our first problem is 8 equals 4 times x. You're trying to get x by itself. The inverse of multiplication is division, so I'm going to divide both sides by 4. 4 divided by 4 is 1, so I'm left with x. 8 divided by 4 is 2, so my solution is 2 equals x. Okay, I'm going to check it. I want to know if 8 equals 4 times x, where x can be replaced with 2. 4 times 2 is 8. That's what's supposed to equal, and so we know we did it right. Negative 3x equals 18. Okay, this is a negative 3, so should we be adding 3 to both sides? The answer is no, because this means negative 3 times x. So the actual operation in this problem is still multiplication. So I'm going to divide both sides by negative 3. Negative 3 divided by negative 3 is positive 1. I'm left with x. 18 divided by negative 3 is negative 6. So once again, we continue to use those integer rules. If you divided both sides by a positive 3, you would get a positive 6 in your answer, which would not lead to the correct answer in your problem. So looking at a check, I would take negative 3 times my x, which is negative 6, and I want to know if it equals 18. Well, we know a negative times a negative is a positive. This is positive. And 3 times 6 is 18, so it does check out. Okay, now we get into some decimals. So I have negative 2.3g equals 2.13. So this is multiplication again, so I'm going to divide both sides by negative 2.3. Okay, so looking at the rules for division, first of all, we know a positive divided by negative would be a negative answer. So I'm going to put 7.13 underneath and 2.3 on the outside. When we divide decimals, we need to move that decimal over one place. So we do the same to the inside number. Then I'm going to bring it to the top. So 23 goes into 71. I'm going to say 3 times. Get 969. So I put a 3 above the 71 and subtract 69 here. You get 2, bring down the 3. 23 goes into 23 once, and it goes in evenly. Okay, so I have 3.1. So 7 and 1300ths divided by 2 and 3/10 is 3.1, but it was a negative 2.3. So I need to apply this negative sign because I have positive divided by a negative. So I get G equals negative 3.1. That's my solution. Okay, and then you can check it once again. Negative 2.3 times negative 3.1. I have 1 times 3, which is 3. 1 times 2, which is 2. Add a 0. 3 times 3 is 9. 3 times 2 is 6. So I have 3, 11, and then I'm going to bring it over 2 places. And once again, a negative times a negative is a positive, so it checks out. That's what it's supposed to equal. Okay? And our last one, I'm once again trying to solve for E. I have 1/2 times E equals 1/4. So the opposite of times E is to divide both sides by 1/2. Now when I take 1/2 divided by 1/2, remember you are flipping and multiplying. So I flip the second number, so it's going to turn into 1/2. Then just flip the second one and multiply. So if I think about my cross-reducing here, these are both cross-reduced to 1. I would divide by 2. And you're left with just 1/1 or 1. So that does leave me with just E. So that cancels out to E. Then I'm going to do 1/4 divided by 1/2. Flip the second number. So I have 1/4 and then 2/1, and I'm going to multiply. Okay, I'm going to cross-reduce again, and I'm going to cross-reduce by 2. Becomes 1, and this becomes 2. So 1 times 1 is 1. 2 times 1 is 2. So 1/4 divided by 1/2 is 1/2. So I have E equals 1/2. Then to check it, I would plug in E as 1/2. So I have 1/2 times 1/2. And I want to know if it equals 1/4. Well, 1 times 1 is 1. That checks out. 2 times 2 is 4. So I know this does indeed work. Okay? So we're still using the inverse operations. Inverse of division, or I'm sorry, multiplication is division. Whatever you do to one side, you must do to the other. And remember, the point is you're trying to get the variable by itself. So when I divide, I'm dividing by that same number because any number divided by itself is 1. Okay? As always, thanks for watching. Make sure if you have any questions, you ask Mr. Kohlinger or myself tomorrow.